We have seen from the property of sign of trigonometric function that is cos of negative angle is always positive, whereas sine of negative angle is negative of the sine function. So what is the formula of cos x plus y? Cos x cos y minus sin x sin y. Angles multiplied by a natural number or any whole number. So we know what is cos x. We'll just derive the formulas or identity related to cos, sine and tan for 2x, 3x angles. Hello everyone, a warm welcome to one and all. This is your Shruti ma'am lecturing in Vidhyaashram, the Temple of Excellence, Mysuru. In this session, we are going to take up about the trigonometric functions on compound angles. So we have studied the trigonometric functions of allied angles, and here we are going to study the trigonometric functions of compound angles. So what does the compound angles mean? So any angle in the form of an x plus y or x minus y. So the difference of two angles or the sum of two angles or nothing but the compound angles. Also, we are studying about the multiple angles. What do you mean by this multiple angle? Multiples of angle. Suppose we have an angle x, then what is the angle 2x, 3x in terms of trigonometric functions? So we have a very important proof in terms of geometry, that is the sum of any two angles in terms of cosine function, that is cos of x plus y is equal to cos x cos y minus sin x sin y. Now this can be proved using the unit circle. So for that purpose, I am taking an unit circle. You can see here I have taken angle x, angle y and angle minus y inside the unit circle. So therefore, the coordinates of angle x at point P1 is cos x comma sin x, and for P2 I have taken it as x plus y because I have taken this as the original ray. So therefore, this complete angle is x plus y, hence the coordinate is written in the form of cos x plus y comma sin x plus y. The same angle I have measured in clockwise direction, which is minus y, hence their coordinates is cos of minus y comma sin of minus y. So this is the point P3, this is the point P2, and P4 we can clearly say, since this is a unit circle, the coordinate is 1 comma 0. So from the figure we can write here P1O P4 is your angle x. Next we have P2O P4 is your angle x plus y, and P3O P4 is your angle minus y. So based on the measurement of angle, we know that whenever an angle inside a sector is an x radians, then I can write the coordinates in terms of cos x comma sin x. So that is why all the angles here are mentioned in terms of cos and sin. Now then from the diagram, the next thing you need to see here, join P1 and P3 and P2, P4. So when you join these two sides, you will get two triangles there. So the two triangles are, the first triangle is P1O P3 and the second triangle is P2O P4. Now look here in the diagram, OP4, OP1, OP2 and OP3. What are these? These are radius of this unit circle. Hence, you can clearly say they are all equal. So that means two sides of a triangle are already equal. So therefore, we can say that the third side can be equated. That is P1, P3 can be equated to P2, P4. Now squaring on both sides, we will get P1, P3 whole square is equal to P2, P4 whole square. So why I am taking a square root here? Because to find the distance of P1, P3, I can use the distance formula. So distance formula contains the square root quantity. So to remove that square root quantity, we can just square the distance P1, P3 here. Now using distance formula, we can see the distance between P1 and P3. So therefore, P1, P3 square can be written as, so we can write this in the form of x2 minus x1 whole square plus y2 minus y1 whole square. Hence this can be written as cos x minus cos of minus y whole square plus sin x minus sine of minus y whole square. So we have seen from the property of sine of trigonometric function that is cos of negative angle is always positive, whereas sine of negative angle is negative of the sine function. So therefore here I can write this as cos x minus cos y whole square. So here it is sin x minus sin y, so this becomes plus sin y whole square. So using the algebraic identity a minus b whole square and a plus b whole square, we can write here cos square x plus cos square y minus 2 cos x cos y plus sin square x plus sin square y plus 2 sin x sin y. Now here cos square x plus sin square x is an identity again whose value is 1. Cos square y plus sin square y is again an identity with the same angle, so therefore its value is 1. And here you can see from these two terms, 2 is a common factor. So when I take minus 2 as a common factor, I am left with cos x cos y minus sin x sin y. So this is P1 P3 whole square. So now we got P1 P3 whole square as the total 2 minus 2 cos x cos y minus sin x sin y. Now let's see what is P2 P4 whole square. Now P2 P4 whole square, again using the distance formula. So this is P2 P4. I can write this as cos x plus y minus 1 whole square plus sin x plus y minus 0 whole square. And here this can be expanded as a minus b whole square formula. So therefore it is cos square x plus y plus 1 minus 2 cos x plus y. And here sin x plus y minus 0 becomes sin x plus y. So whole square gives you sin square x plus y. Now you can see cos square and sin square with the same quantity x plus y, which is an identity again. Hence here you will get it as 1 plus 1 minus 2 cos of x plus y. So therefore P2 P4 square is 2 minus 2 cos of x plus y. So we have got the value of P1 P3 whole square. We have got the value of P2 P4 whole square. We have taken both of them are equal. So using that condition, that is P1 P3 whole square, P2 P4 whole square. So this implies here P1 P3 is 2 minus 2 cos x cos y minus sin x sin y. And here you have 2 minus 2 cos of x plus y. So you can see plus 2 get cancels on both sides. Then you are left with minus 2 cos x cos y minus sin x sin y minus 2 cos of x plus y. Again the multiple minus 2 get cancels. So you are left with cos x cos y minus sin x sin y, that is equal to cos of x plus y. So thus we can conclude cos of x plus y is equal to cos x cos y minus sin x sin y. Hence we have proved the identity cos of x plus y as cos x cos y minus sin x sin y using the unit circle. So this can form as a base for many more identities yet to come together. So let's see the application of this identity towards few more identities. Next we have prove that cos of x minus y is equal to cos x cos y plus sin x sin y. So we know the formula cos of x plus y as cos x cos y minus sin x sin y. So here instead of plus y, I need minus y. So therefore, replace y by minus y. So wherever you have y, just change it as minus y. So here I'll get it as cos x minus y, cos x, cos of minus y, sin x, sin of minus y. We know that cos of negative angle is positive. So therefore, I can write it as cos x, cos y minus sin x. Sin of minus y is minus sin y. So therefore, it becomes plus sin y here because we have minus there. So that is, we get cos x minus y as cos x cos y plus sin x sin y. Next one, prove that sin of x plus y is equal to sin x cos y plus cos x sin y. We know by the property of an allied angle, sin function can be converted to cos and cos can be converted into sin. How? We know that sin pi by 2 minus x can be taken as cos x, or cos x pi by 2 minus x can be written as sin x. So here I need the formula of sin x plus y. So let me express sin x plus y as cos pi by 2 minus x plus y. Because cos of pi by 2 minus x is sin x, hence sin x can be written as cos of pi by 2 minus x plus y. Now here cos, I'll rearrange the term here, pi by 2 minus x plus y. Now this is in the form of cos x plus y. We know the formula of cos x plus y. So what is the formula of cos x plus y? Cos x cos y minus sin x sin y. So here I'll write this in the form of cos x. Here in the place of x you have pi by 2 minus x. So cos x cos y minus sin x sin y. So thus here we know that cos pi by 2 minus x means sin x. So we'll get this as sin x cos y. Here I'll rearrange the term as cos pi by 2 minus x minus y. Now clearly you can observe this is in the form of cos x minus y. That means this complete thing you can take it as x. So what is the formula of cos x minus y? Cos x minus y is cos x cos y plus sin x sin y. So therefore this can be written as cos x cos y plus sin x sin y. Now here cos pi by 2 minus x can be written as sin x. This is same cos y, and sin pi by 2 minus x can be written as cos x sin y. So thus we will get sin of x plus y is equal to sin x cos y plus cos x sin y. So the same formula can be extended to sin of x minus y. So which is sin x cos y minus cos x sin y. So to get this formula, just write this formula and replace y by minus y. You will get sin of x minus y as sin x cos y minus cos x sin y. Next, prove that tan x plus y is equal to tan x plus tan y divided by 1 minus tan x tan y. So now here, let me take tan x plus y as sin x plus y divided by cos x plus y. So sin x plus y means it is sin x cos y plus cos x sin y. Cos x plus y can be written as cos x cos y minus sin x sin y. So now we have two terms on the numerator and two terms on the denominator. So let us divide both numerator and denominator terms by cos x cos y. So therefore here I'll get sin x cos y by cos x cos y plus cos x sin y divided by cos x cos y whole divided by cos x cos y divided by cos x cos y minus sin x sin y divided by cos x cos y. So therefore, tan x plus y is equal to sin by cos becomes tan here, cos y cancels, cos x cancels, sin by cos is tan y whole divided by cos x get cancels, cos y get cancels. So here you will get 1 minus sin by cos is tan x, again sin by cos is tan. So this is the identity of tan x plus y. The same function can be expressed for difference of x minus y. So here you can just replace y by x, then you will get tan x minus y as tan x minus tan y whole divided by 1 plus tan x tan y, because tan of negative is minus tan y. So minus tan y becomes plus in the denominator, minus in the numerator. Next, prove that cos pi by 2 minus x is equal to sin x. So this is an allied angle property which we already know, but this can also be proved using cos x plus y or cos x minus y formula. So we know that cos x minus y is cos x cos y plus sin x sin y. So in the place of x here you have pi by 2. In the place of y you have x. So just replace the terms as pi by 2 and x. So we will get cos pi by 2 cos x plus sin pi by 2 sin x. So what is cos pi by 2? 0. So 0 into cos x. What is sin pi by 2? 1. 1 into sin x. So therefore 0 plus sin x, which will get you as sin x. So that is cos pi by 2 minus x is sin x. Similarly, we can also get cos pi by 2 plus x as minus sin x. Next, we will take few identities on multiple angles. So what are these multiple angles? Angles multiplied by a natural number or any whole number. So we know what is cos x. We'll just derive the formulas or identity related to cos, sin and tan for 2x, 3x angles. So now here prove that cos 2x is equal to cos square x minus sin square x, which is also equal to 2 cos square x minus 1, which is also equal to 1 minus 2 sin square x, which is also equal to 1 minus tan square x by 1 plus tan square x. So thus cos 2x can be written in 4 ways. First one is cos square x minus sin square x. Second one is 2 cos square x minus 1. Third is 1 minus 2 sin square x. Fourth one is 1 minus tan square x by 1 plus tan square x. So now let us prove them one by one. We know the formula of cos x plus y, which is cos x cos y minus sin x sin y. Now in the place of y, replace y by x. So instead of y, if you substitute x, what happens here? Cos x plus x is equal to cos x minus sin x sin x. So this implies cos 2x, because x plus x is 2x, cos x into cos x is cos square x, sin x into sin x is sin square x. So thus my first proof is verified. So let me take this as equation 1. Now let's move on to the remaining identities on the right hand side. We need cos 2x as 2 cos square x minus 1. We know the identity cos square x plus sin square x is equal to 1. Here cos square x can be written as 1 minus sine square x, or sine square x can be written as 1 minus cos square x. So let me use cos 2x is equal to cos square x minus, instead of sine square x, I will take it as 1 minus cos square x. So then I will get cos 2x is equal to cos square x minus 1 plus cos square x, which is equal to 2 cos square x minus 1. So my second proof is verified. Now let me take the same equation 1, that is cos 2x is equal to cos square x minus sine square x. Now in the place of cos square x here, I will just replace it by 1 minus sine square x, and one more sine square x we have, minus we have minus 1 becomes minus 2 sine square x. So this is another identity of cos 2x. That is cos 2x can be written as 1 minus 2 sine square x. Let me take the last one. We have here 1 minus tan square x divided by 1 plus tan square x. So this is the right hand side, and let me show that is equal to cos 2x. So here I am taking the right hand side of the equation. So here let me take tan as sine by cos. Then I will get here 1 minus sine square x by cos square x whole divided by 1 plus sine square x by cos square x. So taking LCM, I will get this as cos square x minus sine square x divided by cos square x on the numerator whole divided by cos square x plus sine square x whole divided by cos square x. So denominator get cancels here. So I am left with cos square x minus sine square x. Here you can see the denominator cos square x plus sine square x. But what is cos square x plus sine square x? The value is 1. So the denominator will become 1. What is cos square x minus sine square x? We can clearly see from the first identity, that is cos square x minus sine square x is nothing but cos 2x. So therefore, this is equal to cos 2x, that is LHS of the given identity. Hence, cos 2x can be transformed into many other functions in terms of cos only, in terms of sine only, or in terms of tan only. So these are few identities of cos 2x. Next, prove that sine 2x is equal to 2 sin x cos x, which is also equal to 2 tan x divided by 1 plus tan square x. So when I say sine 2x, I can use the formula of sin x plus y. We know that sin x plus y is sin x cos y plus cos x sin y. Here also replace y by x. So then this becomes sin of x plus x sin x cos x plus cos x sin x. Now what is sin x plus x? It is sin 2x. Sin x cos x plus sin x cos x is 2 times sin x cos x. So this is the first identity of sin 2x. Now let us show that this equation is equal to sin 2x. So for that purpose, let me consider the right hand side, 2 tan x divided by 1 plus tan square x. Now replace tan as sin by cos, then I will get 2 times sin x by cos x whole divided by 1 plus sin square x over cos square x. So taking LCM, I will get 2 times sin x by cos x whole divided by cos square x plus sin square x divided by cos square x. So cos cancels with 1 time of cos. Cos square x plus sin square x value is 1. So I will get this as 2 sin x divided by 1 by cos x. and 1 by cos x can be taken to the numerator. You will get this as 2 sin x into cos x. So our 2 sin x cos x is nothing but sin 2x. That is the left hand side of the identity. Hence, sin 2x can be written as 2 sin x cos x and 2 tan x divided by 1 plus tan square x. Next, prove that tan 2x is equal to 2 tan x divided by 1 minus tan square x. So, we know the formula of tan x plus y, which is tan x plus tan y divided by 1 minus tan x tan y. Here also replace y by x. So, we will get this as tan x plus x as tan x plus tan x whole divided by 1 minus tan x into tan x. This can be written as 2 tan x divided by 1 minus tan square x. So, this is how we will get the multiple angle in terms of compound angles, just replacing y by x. Now, I can only take the formula of tan x plus y for tan 2x, sin 2x, cos 2x, because if I take x minus y, then it will be in the form of x minus x, where you will get cos 0, sin 0, tan 0. So, which is not a proper way to find the multiple angles. So, therefore, I always use the formula of x plus y to find 2x in terms of cos, sin and tan. So, in this session, we have learnt the proof for trigonometric identities of compound angles and multiple angles. We will take few more identities in our next session. Until then, keep watching, keep learning, keep exploring. Thank you.